Hello everyone, my group and I are presenting you with a walkthrough of our project, which is focused on testing patterns in Flash open source codebase. Our approach for this project is to study and test how each pattern applied to the test is set up, which could help with the flexibility and maintenance of the system. We organize our project into three main units to keep things structured and easy to follow. First one is pattern discussions, where we define the key testing patterns we're analyzing. Second is open source project background, where we examine Flash test suites and understand how testing is set up and maintained. And lastly, test pattern application and refactoring, where we deep dive into actual code and show how specific testing patterns are used in real scenarios. By following this structure, we're aiming not to just identify patterns, but also show how and why they are used. Let's start by defining these patterns we're focused on.
Okay, so for pattern discussion in our project, we focused on two testing patterns, test double patterns and fixture teardown patterns, both of which are highly relevant to Flask testing approach. Test doubles are stand-ins for real components used during testing. In Flask, this often appears as a test client method, which acts as a stub, a simplified object that mimics actual behavior so we can test route responses without starting a real server. Fixture teardown patterns, on the other hand, help ensure the test environment is clean after each test run. This is essential in Flask, where global state or configuration might persist between tests. Teardown patterns prevent side effects from one test affecting others. Together, these patterns help keep Flask's test suite isolated, predictable, and maintainable, which are the core goals of effective testing.
Flask is a lightweight Python web framework used to build web applications and APIs. It's focused on simplicity, flexibility, and giving developers full control. On the right, you can see how Flask fits into a typical web architecture. Requests come from the browser, go through a web server into Flask via WSGI, and the responses are returned back to the client. For this study, we analyzed the Flask GitHub repository found at the link below. Flask test suite is located in the tests folders of the GitHub repo. It uses the PyTest framework and indicates a wide range of test files. These files cover routing, request context, sections, templates, signals, and more. On the right, you will see a snapshot of the actual test directory structure. This helped us get familiar with how the suite is organized and what areas are being tested. To avoid duplicating setup logic across tests, Flask uses fixtures which are stored in a shared file called comforttest.py. These fixtures are injected into each test file, helping keep tests clean and reusable. A good example is this app fixture, which initializes a fresh Flask instance. This let tests run in a controlled environment without interferences from previous tests. You can also see the full code for the fixture on the right, taken directly from GitHub. Based on what we saw in the test suite, we identified three key testing patterns from the XUnit test pattern book. The first is the test double pattern, which includes mocks and stubs to simulate behavior. The second is fixture setup and teardown, handled with PyTest and context managers. And the third is the value pattern, where the test checks if the output equals a expected value. These patterns make Flask test module clean and effective at catching bugs. Here is an example of the test double pattern, specifically using a mock object. In this file, Flask tests teardown logic by assigning a mock handle and verifying it gets code. As you can see in the diagram, the app triggers the mock handle and then the test checks that access code once passes. This let us test the interaction without needing a real handle. It isolates logicals and ensures the test is focused only on the app context teardown. Based on our review, we found that the Flex test suite is clean and well structured. It makes excellent use of PyTest fixtures and mocks. However, we also noticed a few weaknesses. Some teardown steps happen implicitly without being verified, and some tests lack clear naming or comments. We recommend adding explicit teardown verification, improving test names, and using inline comments for mock logic. These improvements could help future contributors better understand and maintain the test suite. That wraps up my section on the project background. Next, we will take a deep look into specific testing patterns used in Flask.
Let's talk about fixture teardown pattern in Flask test suite. Here's one of the tests from test_app_context.py, test app tearing down. This test is validating that the teardown callback registered with an app teardown app context gets properly called when the application context is popped. What's happening here? First, we create a list cleanup stuff to track if the teardown function runs. Inside the test, we define a cleanup function that appends the exception, if any, to that list. After entering the exiting app context, we assert the cleanup stuff equals to none, confirming the teardown ran and there was no error. Now here's a more complex example. Test app tearing down with unhandled exception. In this case, we intentionally raise a value error inside the Flask root and check the teardown still runs, even when there's an unwanted exception. We verify that by the teardown function receives the exact value error object, and we assert that it was the only item in the cleanup list. So again, this test isn't just checking teardown run, it also verifying the error was correctly passed into the teardown logic, which can be important for logging, recovery, or cleanup decisions in real apps. So why is this pattern so critical in Flask? Because Flask relies heavily on context objects, app requests that live in thread local storage. If those contexts don't get cleaned up properly, they can leak across tests or between requests, leading to a flaky test or even hard to reproduce bugs in productions. By applying this fixture teardown pattern, Flask ensures every test is self-contained and every piece of context is safely reset between runs. That wraps up the teardown pattern. Next, we'll explore another family of patterns, test doubles, including fakes, mocks, and dummies, and see how Flask uses those to simulate behaviors in tests.
Now, let's take a closer look at how Flask Test Suite applies the test double fake testing pattern using real examples from the testRequests.python file. One of the clearest uses of this pattern can be found in the function testTrustedHostConfig. Here is a screenshot of the code. In this test, we see the use of the app.testClient method. This is where the fake test double comes into play. The testClient method returns a fake client object that simulates HTTP requests to the Flask app. If it's not a real browser or an HTTP client, it's a simplified version that mimics the behavior of a real-world request and response cycle. This fake client allows us to make GET, POST requests, and test the responses without spinning up a live server or making real network calls. So why use fake here? Well, the benefits include, number one, speed. Test runs faster because there's no overhead from actual server setup. Number two, isolation. We can test Flask routing and error handling logic in a controlled environment. And lastly, number three, is precision, where we're only testing what we care about. In this case, whether Flask accepts or rejects requests based on the trusted host config. And so, a test double fake replaces a complex or external dependency, in this case, a live HTTP client, with a simplified but functional substitute that makes testing easier, faster, and safer.
So now I will walk you through how a mock, which is a type of test double pattern, is used in plus test suite. So the mock is used in the test function test workspace pass-through errors. So this test checks how plus configure error handling when it launches the development server. Specifically, it wants to know if Flash sets the pass-through errors option correctly. So to give more background, let's go to the app.py. So this run simple function is imported from the worksug um, and called in Flash own source code inside the app.py. So that's the method Flash uses to run its dev server. So by mocking it, we're verifying that class behaves correctly without ever starting a real server. So now that we know what run a simple function does in class, let's take a look at how the test replaces it with a mock. So here's the test. Here's the code, and I'll break down what each part is doing. So, uh, so the RB is a simple dictionary used to capture the test result, and the run simple mock is the baked version of the run simple that we saw earlier. It doesn't run a server; it's just check what value was passed into the pass-through error and store it. So the monkey patch set attribute replaces the real work serving that runs simple with our mock, and the app that runs the app, but behind the scene it's calling the mock, that not the real server function. So this is a perfect use case for mock pattern because the test doesn't care about actually launching the server. It's just want to verify what would have been passed to run simple function. So instead of relying on the real server logic, we intercept the call and inspect it with our mock. That's exactly what makes it a mock. Now let's take a look at another type of test double pattern, which is the dummy. So a dummy is the simplest kind of test double. It's just a placeholder. You pass it into a function to satisfy an argument, but it's never really actually used. So there's a good example of this in plus test, which is this test function. So this test is just checking if plus still cleans up everything properly, even if something went wrong before. So it pretends that error happened earlier by raising an exemption error, but that error doesn't actually do anything because it's caught right away. Then it's start a new app context and closes it. So at the end, the test just check if plus run the cleanup like it was supposed to. So the test raises an exception error dummy here, but that exception isn't used anywhere. It doesn't affect the app context. It doesn't change the behavior. It's just there to simulate that something happened earlier. So That's make it a dummy. It passes around, but it doesn't matter. So so that's how Plus uses a dummy pattern to simulate a situation without changing anything. S- Um, and it's a placeholder that lets the test focus on what what's really matter. All right, to wrap everything up, we took a closer look at how real testing patterns show up in Plus. We showed how Plus actually uses them in real tests. Each pattern we covered helps solve a specific problem, whether it's avoiding side effects, cleaning up after tests, or just filling in required values. And seeing this pattern in action really shows how they make tests more readable and just easier to work with. So, by understanding these patterns, we can write better tests ourselves, tests that just make more sense and are way easier to work with. And that concludes our presentation. Thank you so much for watching.